Have you ever been part of a project, maybe a huge initiative at work, or even just a massive undertaking in your personal life, where the budget you got approved for and the reality of getting it done were just, you know, existing in two completely different universes?
Oh, absolutely.
Yeah.
It really feels like a universal human experience.
Right.
There's always this eternal gap between the clean theoretical plan on paper and the messy, chaotic reality of actually executing it.
Exactly. The friction between intention and reality. We
Yeah.
see it everywhere. But today, we are taking that highly relatable pain point and, well, we are magnifying it by a few $100 million.
Wow, a few hundred million.
Yeah, literally. Because we are diving deep into the multi-million-dollar graveyard of what the tech world calls legacy system modernization.
Right. A huge topic.
And for anyone listening who isn't deep in enterprise tech, this refers to those massive projects where a bank or, say, an airline tries to update the ancient computer systems that run their core operations.
The terminology itself is almost deceiving. Modernization. Well, it implies a smooth, linear upgrade, right? Like trading in an old car for a new one. But the reality of touching these decades-old systems is incredibly dangerous. I mean, it is fraught with risk.
And to figure out why these massive projects become basically financial sinkholes, we are pulling from a really fascinating stack of sources for this deep dive today.
We really have some great material.
We do. We've got a comprehensive article by Suyash Sumaru titled What CFOs Actually Care About in Legacy Modernization, which was published by Kudora.
Right.
And to make this incredibly tangible, we actually have a stack of internal system screenshots straight from Kudora's AI-driven platform.
Which is amazing.
It is. It's letting us look over the shoulder of the people doing the actual work.
And that is going to be crucial for you as the listener. We aren't just talking about abstract business theory here.
No, not at all.
We are going to look directly under the hood at the code level to understand the mechanics of failure and the mechanics of the solution.
And that is the mission for this deep dive. We are going to uncover why these critical tech upgrades usually end up being what the article calls an ROI illusion.
ROI illusion.
Yeah. We will explore the hidden financial failure points buried in code that is sometimes 30, 40 years old. And finally, we will discover how artificial intelligence is stepping in to act as a translator, essentially bridging the massive gap between engineering execution and boardroom expectations.
This concept of translation is vital because right now, those two groups, the executives in the boardroom and the engineers in the server room, they are effectively speaking different languages.
Like completely different realities.
Exactly. Living in different realities and measuring success by completely different metrics.
Okay, so let's unpack this. To really understand why these projects fail, we have to look at those different languages. Let's start with the boardroom.
Okay.
Think about the chief financial officer. What language are they actually speaking when they sign off on a $50 million modernization project?
Well, they are speaking the language of capital allocation. I mean, for a CFO, taking a decades-old banking ledger or a massive healthcare claims database and moving it to the cloud, that is not a technology initiative.
Wait, it's not?
No, not to them. It is a pure financial investment. That $50 million is competing against every other investment the company could possibly make.
Like buying a smaller competitor.
Exactly. Or they could expand into a European market. They could build a new physical factory. So when they allocate that capital to IT, they fund outcomes.
Right.
They expect a clear return on investment, or ROI. They demand cost predictability. And crucially, they want to see that value realized within a very specific, unforgiving window, usually 24 to 36 months.
Just if the project takes 5 years.
The whole market has changed.
Yeah, the
Right.
entire business landscape has shifted, the competitors have moved on, the interest rates have changed. The original business case is just completely dead.
Precisely. They measure success strictly by asking, did this massive expenditure reduce our daily operational costs? Did it allow us to launch products faster and accelerate revenue?
Did it fundamentally improve our profit margin?
Exactly. It's all financial.
But then you walk down the hall, grab a coffee, and sit down with the engineering delivery team. And they are measuring success entirely differently.
Completely differently. The delivery teams are tracking technical milestones.
Right.
They are looking at data migration completion percentages. They are measuring system uptime. They are checking whether the new cloud deployment architecture is fully provisioned.
You know, it's like doing a massive home renovation. The homeowner, the CFO in this case, they care about staying under budget and actually being able to cook Thanksgiving dinner in the new kitchen.
Yeah, that's the outcome.
That's the outcome. But the contractor, the delivery team, is high-fiving because the drywall is up, the electrical is routed, and the pipes don't leak.
Right, they did their job.
They might have taken an extra 6 months and blown the budget by 40%, but the contractor is saying, hey, look, the water runs. Meanwhile, the homeowner is financially ruined. The technical success does not guarantee the financial success.
If we connect this to the bigger picture, that structural misalignment is the root cause of the ROI illusion.
The ROI illusion.
Right. You have an initiative approved on strict financial terms, but it is executed and evaluated on purely technical terms. A system can be technically migrated. The pipes don't leak, to use your analogy, and still completely fail to reduce the company's operational costs or make them any faster to market.
And because of that disconnect, the results are just predictably disastrous. Budgets expand wildly, timelines stretch out endlessly, delaying any actual value realization.
And executive confidence just evaporates.
Totally evaporates. The article emphasizes that financial objectives cannot just be these abstract targets set at a kickoff meeting and then ignored for 2 years. They have to be measured continuously throughout the execution.
And that brings us to a critical transition. If the boardroom and the server room are misaligned from day one, we really need to understand the mechanics of the bleeding.
Where the money actually goes.
Exactly. We know there is a theoretical disconnect, but the source material gets very specific about the practical failures. Where does the budget actually vanish to?
Well, the article actually breaks this down into 4 critical financial blind spots. And let's walk through them because this is really where the rubber meets the road.
Let's do it.
First, there are underestimated discovery costs. You start the project, and suddenly the team realizes the ancient system is vastly more tangled and complex than anyone in management originally thought.
Which leads directly to the second blind spot, which is extended timelines.
Yeah.
Every single week of delay is a financial liability.
Right.
Going back to the CFO's mindset, if you expect payback in 24 months and the project suddenly takes 48 months, the financial viability of that entire investment just collapses under the weight of its own carrying costs.
Yeah, it becomes a literal money pit. Then you have the third blind spot, which fascinates me, an over-reliance on expensive, highly specialized talent. We are talking about legacy systems, often written in outdated programming languages like COBOL.
COBOL is the perfect example. It was created in the late 1950s, yet it still powers a massive chunk of the global financial system today.
Which is wild to think about.
It is. And the developers who originally wrote these systems are largely retired. So there is a very limited supply of engineers who actually understand it.
Which drives their price up.
Exactly. Which means you are paying premium consulting rates just to interpret the old system, long before you even start building the new one.
And that ties into the fourth and perhaps most damaging blind spot: rework. This is the massive inefficiency caused when teams misinterpret what the old business logic was supposed to do, build the new feature incorrectly, realize it breaks a downstream process.
And then they have to scrap it and start all over.
Exactly. Scrap it and start over.
Rework is the ultimate budget killer. It consumes time, money, and morale all simultaneously.
Wait, hold on. Before we blame this all on the complexity of the code, so why can't a company just hire a bunch of junior developers to read the old manuals and document what the system does before they start coding?
That seems logical, right?
Yeah, it seems like a solvable problem.
Yeah.
Just read the old manuals, map out the logic, and draw up a clear blueprint before anyone writes a single line of new code. Why do we need the expensive COBOL veterans or risk so much rework?
It is the most logical question to ask, and it hits on the absolute root cause of all these failures, what the article calls the visibility gap. You cannot just sit a junior developer down to read the manuals because 40% of these legacy systems are completely undocumented.
Wait, really? 40%? Almost half of the critical systems running major enterprises have zero documentation.
Easily. I mean, the manuals you're picturing either never existed in the first place or they were last updated during the Clinton administration.
No.
Yeah. Over decades, these systems have evolved through thousands of incremental patches, quick late-night fixes, and workarounds. The business logic, the actual rules governing how a bank processes a loan or an airline routes a ticket, is trapped deep inside massive monolithic code bases.
It feels like a massive game of Jenga. Like over 30 years, hundreds of different developers have pulled out blocks, glued new ones on the outside, and somehow the whole thing is still standing.
Yes.
But nobody actually knows how the weight is distributed anymore.
That is a brilliant way to conceptualize it. A game of Jenga where the blocks are invisible and the tower is holding up the global financial system.
That is terrifying.
It really is. When a modern team goes in, dependencies remain completely hidden. They touch a piece of code that looks isolated, and suddenly they have broken a compliance reporting process they didn't even know existed.
And that's not just a technical issue.
Right. This isn't just a technical hiccup. The article is clear. These are financial risks disguised as execution challenges. If you lack visibility into the Jenga tower, expanding the scope of the project is just inevitable.
You cannot just read the manual because there is no manual. And the people who built the system are gone.
Exactly.
You need a completely new way to map the unknown. And this is where I want to pull in the visual evidence we have from the Code Aura platform, because it really illustrates how artificial intelligence is stepping in as the ultimate cartographer to solve this visibility gap.
Right. Traditionally, building that map manually would take years of expensive human consulting time. People manually reading code line by line, trying to trace the connections.
But we are looking at screenshots of how this AI builds a comprehensive understanding before any execution even happens. Let's look at the architecture mapping first.
Okay.
We have this vibrant visual map, and right in the center is a node labeled Oz Mainframe Modernization Card Demo.
And standing out from that central node, the AI has instantly mapped out all the dependencies. You see it connecting to specific files with a .cbl extension. Which are the COBOL programs themselves, right? Exactly, those are the COBOL programs. And it also connects to files with a .jcl extension. JCL stands for Job Control Language, which is basically the script that tells the mainframe how to run those COBOL programs.
Oh, I see.
The AI doesn't just list them, though. It visually connects them, showing the exact flow of execution.
And in another screenshot of their file explorer, the AI has automatically tagged entire folders of code with labels like IMS, DB2, and CICS.
Let's translate those terms for the listener because they represent massive complexity. IMS and DB2 are very old, highly structured database systems.
Okay.
And CICS is a transaction processing system originally designed to let thousands of users interact with the mainframe simultaneously. Think of, like, ancient green screen terminals at a bank teller's desk.
Right. The AI isn't just reading text. It is reading millions of lines of code and instantly categorizing the entire historical tech stack. It actually understands the context of the technology.
Here's where it gets really interesting. Mapping the architecture is just the foundation. Where the AI fundamentally changes the game is how it extracts the business logic.
This part is huge.
Yeah. We have a screenshot here breaking down a specific cryptically named program called CBACT01C. A human developer would look at that name and have no idea what it does.
Not at all.
But the AI has actually parsed the syntax tree of the code, analyzed it, and outlined its exact business purpose in plain English. It simply says, account data processing.
And it goes much deeper than just a high-level summary. It details the exact mechanism of the program. It shows how the software extracts core account information, reformats it, and applies date formatting. But look closely at the specific business rule the AI surfaced from the depths of the code. Oh, I'm looking right at it. The AI generated a clean logic summary and highlighted a hidden, hard-coded rule. It says, if current cycle debit is 0, default to 25.00.
Yeah.
That is incredible. Think about the implications of that. Somewhere, decades ago, a programmer hard-coded a bizarre rule that if an account debit hits 0, it defaults to $2,525.
Imagine the fallout. If a modernization team doing this manually missed that one specific line of code hidden in a million lines of COBOL.
Which they absolutely would.
Right. The entire accounting system of the enterprise would break on day one of the new launch. Accounts would be zeroed out, balances would be wrong, and the company would face massive financial and regulatory penalties.
And to find that hidden Jenga block traditionally, you would need to pay that expensive, specialized COBOL veteran to slowly comb through lines of syntax for months.
Months of work.
Here, the AI extracts it instantly. It completely democratizes the knowledge. You no longer need to be a mainframe expert to understand what the mainframe is doing.
And by democratizing that knowledge, you directly address those 4 financial blind spots we talked about. You eliminate the underestimated discovery costs because the AI executes the discovery phase for you.
You cut the reliance on specialized talent.
Exactly. And you drastically reduce the risk of costly rework because you aren't guessing what the business logic is anymore. You have a perfect map.
So the AI is a brilliant cartographer. It parses the syntax, maps the dependencies, and gives the engineers a perfect blueprint. But how does this AI augmented reality translate back to the boardroom?
That's the real question.
Right. How does tracing old databases keep the CFO happy with their strict demands for cost predictability and speed?
That is the core of the AI's value as a translator. It takes deep, chaotic technical reality and translates it into safe, bounded financial investments. Let's look at the screenshot showing how the AI handles impact analysis.
Okay, the Brazilian tax ID example. This perfectly illustrates the translation. Imagine you're a multinational company operating in Brazil, and the government passes a new regulation.
Happens all the time.
Currently, the Brazilian tax ID, the CNPJ, is a 14-character numeric ID. The new regulation mandates it must change to a 14-character alphanumeric ID.
In a traditional legacy system, a regulatory change like that is just a nightmare scenario. It triggers an open-ended discovery project. You have to find every single instance where that ID is stored, processed, printed, or reported across the entire system.
Right.
When the CFO asks, how much will this cost to comply with the new law? The engineering team has to say, we have no idea. Give us 6 months just to look.
Which completely destroys any cost predictability. But in the screenshot we have here, the user interacts with Elliot, Codora's AI chatbot. They don't write a complex search query.
No, it's so simple.
They literally just type in plain English, I want to change the Brazilian tax ID from 14 numeric to 14 alphanumeric. I want to do an analysis to understand what needs to be changed.
Notice how Elliot responds. It isn't just doing a simple text search for the word tax ID. The AI uses deterministic data lineage.
What does that mean exactly?
Meaning it mathematically traces the exact path that piece of data takes as it moves through the system's memory. It identifies the exact legacy database file, noting it's in Adibus, which is an older pre-relational database structure. It finds the extract mapping.
It maps the entire downstream ripple effect. It lists the specific maintenance program that accepts the user input, the extraction program, and 4 specific downstream COBOL reports that will all crash if they aren't updated to accept letters instead of just numbers.
What's fascinating here is how this alters the financial conversation. The engineering leader can walk into the boardroom not with an open-ended request for a 6-month discovery phase, but with a precise, bounded scope of work.
They have actual numbers.
Right. They can say, here are the exact 12 files we need to change. It'll take exactly 400 hours. It will cost exactly this much, and we will guarantee compliance by the regulatory deadline. That is the definition of cost predictability.
It also massively accelerates the time to value, which fits perfectly into that 24 to 36-month window the CFO really cares about. We have one final screenshot here called the Modernization Mapping Summary.
This is the interoperability analysis. It demonstrates how the AI doesn't just understand the old code, it knows exactly how to architect the modern replacement.
It acts as a translation matrix. The AI looks at that ancient CICS transaction, those old green screen teller systems we mentioned earlier, and instantly maps the equivalent logic to a modern REST API endpoint using Spring Boot, which is how modern web applications communicate.
Exactly.
It takes a vsam KSDS indexed file, which is essentially a very old, rigid way mainframes store data in flat files, and maps it directly to a modern relational database, which is how today's apps store data in flexible, easily searchable tables.
This specific capability is cutting what used to be months of manual architectural planning down to seconds. From a financial perspective, what does that mean? It means drastically shorter delivery cycles.
You aren't waiting 3 years for a transformation project to show its first result.
Exactly. The article presents a very stark before and after dynamic. The traditional model guarantees unpredictable costs, agonizingly long timelines, high dependency on rare human labor, and delayed ROI.
A massive headache.
Totally. But the AI-augmented model provides controlled budgets, scalable modern teams, and faster payback. You capture value much earlier, which is the ultimate goal of capital allocation.
So what does this all mean? We have journeyed from the theoretical disconnect in the boardroom, dug into the hidden financial blind spots like the Jenga tower of undocumented code, and seen how AI actually parses syntax and traces data to solve the visibility gap.
I think it means there is a new executive mandate taking shape. For a very long time, legacy modernization was viewed as a necessary evil.
Like going to the dentist.
Yeah, it was a painful technology upgrade you just had to suffer through and hope you survived. But now, with the visibility AI provides, it must be treated as a rigorous, measurable investment strategy.
If you take one thing away from this deep dive, it is the core lesson from the source material. If you cannot predict the cost of modernization, you cannot predict its value.
Absolutely.
Success is no longer measured by whether a system was finally painfully migrated to the cloud. Success is measured strictly by whether it delivered the promised financial outcome. Did it reduce operating costs? Did it improve efficiency? Did it lower risk?
And for you, the listener, there's a much broader application here. Whether you work in technology, finance, marketing, or you are just managing a complex personal project, it is worth asking yourself, where in your own life are you focusing purely on technical completion? Where are you celebrating because the drywall is up, even if you are entirely missing the actual financial or strategic outcome you set out to achieve?
It is incredibly easy to lose the forest for the trees when you are down in the weeds of execution.
You really have to continuously tether the daily granular work back to the ultimate overarching goal.
Which leaves me with one final kind of mind-bending thought to leave you with. We have spent this time looking at how perfectly platforms like CodeAura can map, parse, and translate this legacy business logic. It reads 30-year-old COBOL and instantly translates it into modern web services with total accuracy.
Without losing those hidden rules like the $25 default.
Right, which raises an important question about the future of development itself.
Where is it all going?
Exactly. If AI can perfectly understand and translate code from one generation to the next, well, at what point does the concept of legacy code just disappear entirely?
Oh, wow.
Will future generations of developers ever actually have to sit down and get approval for a massive multi-million-dollar modernization project? Or will AI simply live in the background, continuously translating and adapting the company's systems as new programming languages and frameworks evolve in real time?
That's a wild thought.
Will the very idea of a painful tech transformation just become a relic of the past? You know, something we used to do before the machines learned to rewrite themselves, something to mull over. Until next time.